radiallahu anha online college. May God be pleased with her. Live lesson, A-level maths year 2. This lesson is carrying on with the last few lessons on binomial expansion, but this time we're going to take a look at how do we handle it if you don't have a 1 in the beginning of the bracket. So far up until now, it's always been 1 plus something or 1 take away something. And this time we're going to see how we handle it if there's not just a 1 there. If you're following through in the Pearson Ed Excel book, it's chapter 4, example 6. Okay, Bismillah ar-Rahman ar-Rahim, in the name of God, the most gracious, the most merciful. Let's just do a little bit of factorizing from GCSE, nothing too hard. If I have something like 5 plus 10x and I want to factorize that, then hopefully you'd look for a common factor, which in this case is 5, and then you'd fill in the brackets by whatever I need to times the 5 by to get the numbers I had to begin with. So in that case, it's 1 plus 2x. Okay, nothing hard about that, but let's just go back a step, and instead of writing that 1 there, how else could I have written that? I could have written it as the original number of 5, then dividing by what I put at the beginning of the bracket, which is 5. So it's 5 divided, it's the 5, but now I have to divide by 5 because at the beginning I'm timesing by 5. And then similarly, looking at the 10x that is there, I can fill in the second part of the bracket by starting with the 10x and then dividing by the same 5 that you'll get the same thing as what I had at the beginning as my first answer, because 5 divided by 5 just becomes 1 and 10x over 5 just becomes 2x. So you could carry on and just end up with the same thing. But here, for what we're about to do, it's easier just to leave it like that. And the advantage of this is that it'll work even when there is no common factor. So for example, if I had 7 plus 10x, 7 plus 10x doesn't have a common factor, and at GCSE level you'd be stuck with not being able to factorize this. So what you can do using this technique is you can have anything at the beginning of the bracket. So you can have a 7 if you like at the beginning of the bracket. So now we use the same technique and we say, okay, well, what's going to be in the beginning part of the bracket in here? So you start with what you had. In this case, it's 7 front, which is 7. And then carry on. There was 10x. And what did I have at the front? I had 7. So dividing by 7. Okay. And next thing, again from GCSE, is how do I multiply out? How do I apply a square, a power of 2, to something which has got a plus or a minus in it? So if I take 3 plus 4 and I put a power of 2 there, then what you have to know is that it's wrong to try and apply this to the individual parts. You can't just do 3 plus 4 in brackets squared is equal to 3 squared plus 4 squared. That's not going to work. That's not going to give you the right answer. And just to prove it, 3 plus 4 is 7, and 7 squared, as you know, is 49. So the correct answer to this is 49. But if you do it the wrong way, 3 squared is 9, and 4 squared is 16, and 9 add 16 does not make 49. So that method is wrong. But we can use that method if there was a times sign in between or a divide, then it would work. So we can say if there was a times sign in between, then 3 times 4 is 12, and 12 squared is 144. And if I used the method that I wasn't allowed to use for adding, but if I use it here with timesing, then I can apply the 2 to each bit, 3 squared, and now apply the power of 2 to the 4. That's 4 squared. 3 squared is 9, 4 squared is 16, and 9 times 16 does work out to be 144. So now we're going to combine those two techniques, the technique I just showed you about factorizing and the technique of applying the power to each bit if there's a times in between. So today's example, if, as I mentioned, if you're following through the book, is example 6, but we're looking at where we have to expand something that doesn't just have a 1 at the beginning. So it's 4 plus x, and it's all square rooted. Okay, first let's change that square root sign. Square root really means power of a half. So let's get 4 plus x in brackets and then a power to the half. Then let's remember our binomial expansion formula, which is 1 plus x to the power n is equal to, and then you should know it by now, at least the beginning bits are easy, 1 plus nx plus, and then the fractions carry on from there. I'll just do the first one. So that's power of x squared, n minus 1 on the top, and a 2 factorial on the bottom. Let's get the fraction line in there and then put it in the right position. And hopefully you can spot, you know the pattern by now, so you can do the next term and the next term without too much difficulty. So the problem here is that all the examples that we've done so far always start with the number 1 at the beginning of the bracket. Here we don't have a number 1, we have a number 4. So we can't just rush into that formula. The formula needs to have, only works for examples where we have a number 1 at the beginning. So how do we work with that? So what we're just going to do is make a bit of room. So we're going to have this bracket can come a bit to the left, and then this bracket can come a bit to the right. And now what I'm going to do is I'm going to factorize the 4 plus x. So if I just use different colors, I've got my black bracket with the power of half. And what I just want to do is use what I've learned at the beginning to factorize that. So try to think, you need to answer the next question now. What will I have at the beginning of my bracket? So I'm going to be working on the inside, just on the 4 plus the x. I'm trying to factorize the 4 plus the x. And it'll go to about here. So the question is, what will I have at the beginning? Okay, no response yet. Oh, there is a response. Good, 4. Fantastic, mashallah. So I want to take 4 as the factor to pull out. So 4 can come at the beginning. And then using the technique of before, you had it right. So let's just make a bit more space so we got things lined up. So I'm going to keep the 4, but I'm also going to divide by the number that I'm bringing to the front, which is 4. And then I've got x here. Okay, good. So I factorized. And now remember the basic principle I told you earlier is that if you've got another number in brackets and you've got a power, you can apply that power to each bit as long as it's a times in between, not a plus. So here we do have a times in between because there's a 4 and then an invisible times sign just here. And then this is considered one number. So the 4 times something else, and this power of a half can then be applied to each bit. So I'm going to apply the power of a half to the 4. Let's make a bit of room. So let's apply the power of a half to the 4, and then let's apply the power of a half to the bracket. And now, because there's nothing on the outside of these black brackets, they can be dropped. And 4 to the power of a half, that's the square root of 4, which is just 2. So that's not 2, 1. 4 divided by 4 is just going to be 1, which means now we can apply the formula. So we're just going to apply the formula. We're going to apply it to this brackets, but remember there's a 4 to the half at the beginning, so we just need to make sure that all of our answer gets multiplied by the 4 to the half. So let's do this in a way that we're not going to lose that 4 to the half. Let's bring it underneath. And while I'm just rearranging this, have a think. What do you think is going to be the first opening bit of the expansion? So I'm not going to I'm not going to plus x cubed over 512. The last thing in this question is, for what range is the expansion valid? So what you have to do is look at this bit of the bracket that you did here when you took out the factor to make it 1 at the beginning, and just say the modulus of this has to be less than 1. So the range is where x over 4 is less than 1. The modulus of x over 4 has to be less than 1. Join me for more on binomial expansion in the next lesson. Assalamu alaikum wa rahmatullah. Peace be with you and the blessings of God.